Alright, so I'm going to see if I can't make some videos with my phone. So this is the concatenation proposition for columns. It's one of your homeworks. Hey, here's a way you could start this problem. It might be interesting. Just invent a new matrix C. Let C be the right-hand side, basically, column 1 of B, and so forth. Alright, oops, A, column P of B, like so. And then just look at the ijth component of C. What would that be? So, it would be column J of C, the ith component of that. Alright? Now that's how we get the component of the column. The index, remember the column index is fixed for the jth column. And then I runs from, in this case, from 1 to m. Now, that then, by construction of C, would be A times column J of what? Of B. That's the jth column of C. And of course we still have the ith component of that. Alright? But then, let's see here. This would be, how does this work? Now we're looking at a matrix column product, and so that would be the sum over, let's say, K of A ik column J of B, the kth column, kth component of that. Now here I'm using one of the special cases for matrix multiplication I wrote for you guys in class. Make sure I'm still in the window. Yeah. Sorry if this is sometimes fuzzy. It's the nature of the camera. Anyway, then of course, what do you got? You've got the sum over K of A I K, and let's see, that's B K J. Oh no, I'm sorry, if I write much more I've solved the problem. I better go on. Okay, so that's a little bit on the concatenation proposition. Now, moving along here, oh man, where'd it go? Oh yeah, this outer product thing is kind of weird. Let me just work a quick example of that. So if I have, say, oh, goodness gracious, let's say 1, 0, 1, 0 times A, B, C, D. On the one hand, I've got, let's see here, A, C, or rather A plus C, and then 0, and then B plus D, and then 0, just from matrix multiplication. But on the other hand, it's supposedly equal to, let's see here, column 1 of A, which would be 1, 0, times row 1 of B, which would be AB, and then plus column 2, which would be 1, 0, plus row 2 of B, which would be, well, it's CD. Okay, yeah. Okay, so now the way you do that then is A, 0, B, 0, plus C, 0, D, 0, and as you can see, that is as advertised. If we add these two together, we do get that. So there's an example of how this outer product thing works. And the proof is in the notes that it works in general. but the most right here, you know, again, it's one of these ijth. Look at the ijth component. That's this, but that's exactly the matrix multiplication of the first column with the first row, second column with the second row, all the way out to nth column with nth row. Certainly the most important, well, in my view, the most important application of this is the case when B is just equal to V. It's just a column vector. In that case, we get that the product of the matrix times the column vector is a linear combination of the columns of the matrix. We'll use this a lot a little bit later on. So anyway, I'm just going to stop right here because I want to check on the quality of the video before I get any further. Thanks.